Hello everyone and welcome back to the Python programming language crash course. In today's lesson we will do a brief review of the concepts that we talked about previously, and afterwards we are going to move on into basic data types, strings, working with strings, and I'll also mention in the end some data objects that are more aggregate or composite in their nature. So the Python programming language consists of several themes that are central to it and characterize it very well. First of all, the Python programming language is interpreted, meaning that it doesn't require a compiler and a linker. It only has an interpreter, which is a program that takes our source code, and if it is written well, meaning according to the syntax of the language, it can immediately executed on our system. It doesn't need this process of compilation and linkage such as other languages as C or C++. Python is also strongly typed, meaning that it requires the combination between different data types to be of the same category. For example, if you want to combine two strings, concatenate them. It is allowable. But if you want to, for example, to add a numeric value to a string, this is not part of the Python programming language because it doesn't make any sense. Also, Python induces clean code. It requires from the programmer to adhere to very strict indentation rules that are being part of the syntax of the programming language. We'll talk about and show it in later stages in our studies. Let's talk about some basic data types in Python. We have the numbers, which consist of the integer, the float, and the complex number. We have the strings, which can be either encoded in ASCII or Unicode. It doesn't matter, it depends on the character set that you choose. And we have the booleans, which consist of either of two possible values, true or false. And I want to introduce some generic useful functions because you will probably use them very frequently. First function is the length function, written len, and we pass into it an argument which should be a data object that is meaningful. I mean, strings are meaningful here, numbers probably not so much, because strings we can get the number of characters in that string. If we pass in a number, that's not informative. Type is a function that just returns the type of the object that we passed in. How can we work with strings? Strings are, as we know, a basic data type, so we can just declare them as basic data types that we see in other languages. We pick a name for the variable and then the assignment operator equals and the literal string that we want to keep inside that variable. For example, here I chose my underscore string equals, this is some text. Let's try to do the same in our Jupyter notebook. If you don't have the Jupyter notebook, in order to practice Python in a very accessible way for beginners, why is that so comfortable? Because if you write a command or a piece of code, you can immediately execute it in the notebook. That's why it's so comfortable for beginners. Let's try to put our example, my str equals it is so rainy today. If I press enter, I'll get one more line to put code in, but I want to execute it. To execute it, I put the combination shift and enter. So shift enter and the line is executed. But now I want to see that I actually assigned this literal string to this variable name, my underscore str. So I'll just write the name of the variable and execute. And it returns exactly this string that is being stored inside this variable. So this is how we declare strings. And a very important characteristic of strings is that they are immutable, meaning we cannot modify the characters themselves that comprise the string. We can change the type of the string literal that our variable stores. This we can do, but we cannot go into some specific character in a string literal that is stored in our variable and change that specific character. That is something that is not possible. This is what we mean by immutability of strings in Python. Also, I would like to represent some common actions that we can do with strings. We can index strings, meaning that we can find, locate some specific character in a string by location. Okay, so for example, the I in "It is so rainy today," the first I in the beginning of the sentence, is the 0th position. Its index is 0, and it raises by increments of 1 up to the last character. So if I want, for example, to find the character in the 5th position, I'll write my underscore str. I'll open square brackets and put in the index 5. Execute, and I get a blank space. And you can see that if you actually count the number of characters by in their order, I is 0, T is 1, blank space is 2, I is 3, S is 4, and the next blank space is 5. So it did return me the correct value. So this is how we index strings for specific character positions in the string. We can also slice strings, meaning that we pass the variable name and then we use the same structure of the square brackets, but now we have 3 parts. The starting index for the character that I want to start from, then I have a column, then I put the end index position of the character that I want to end my slice in, and the jump after another column that signifies how many characters would I like to pass each time. Okay, meaning if I start from some starting point, I'll jump, say, 2 characters each time up to the end. Let's see how it is done in practice. I'll write my underscore str, open square brackets, and then I'll write, for example, let's start from the beginning, from index 0th column. Let's end at 10, and let's say we have a jump of 2. Oh, and I'll have to execute it, so shift enter, and I'll get this weird combination of characters as a string, as the resultant string.